Good afternoon, everybody. I'm very happy to have you here in this room. This is our first open lecture for the Erasmus Mundus Masterclass. And this is open because it's just not open to the university, but it's open throughout our webpage to the entire world. So we have people assisting to this different corners of the world. Professor ZALEWSKI is the first invited person that we have to give this lecture here. Professor ZALEWSKI is director of the Center of UNESCO in Poland. He's chairperson of the Department of Biology at the University of UNIV. And Professor ZALEWSKI is only the person that developed the concept of ecohydrology. So I think for starting these open lectures, I can think about nobody better than him. So he's been cooperating with UNESCO for a very long time, with the FAO, with UNIV. So it's a person with very large international curriculum, and well, this presentation is very broad. I hope you for sure will enjoy it very much. And well, Professor, thank you very much for giving this opportunity to us, and I wish you a very nice lecture. Thank you very much.
Thank you very much, Professor Ciano. I would like to say that I'm very honored to be invited here because Professor Ciano and Dr. Alexandra Ciano is just the person who gives the new dimension to ecohydrology. Means they developed coastal ecohydrology. This very important aspect of ecohydrology, as far as almost half of humanity lives in coastal zone. So that's why I'm very honored to be here, and I'm very glad to have the opportunity to share with you some of our work from the, let's say, beginning of the program to the recent developments. So, as far as we know that we're living in Anthropocene, this well-known picture is showing that human is really changing the earth. Changing the earth not only in the sense of using the fossil fuels and converting fossil fuels in energy and also emission of pollutants, but also recently we know, considering the economic crisis, that also change of geopolitical centers are one of the issues which are also disturbing the kind of clear pathways of the which already were just accepted by society and now has to be somehow modified and adjusted. And I think also this picture is showing us that we is warning that using this rate of exploitation of natural resources and without having alternative source of energy like the fossil fuel and such high level of consumption energy, we probably will have to change the pattern of our consumption and also style of living if we are not considering to come to a certain moment to the conflicting situations. So, however, I think everybody agreed what I was saying about that emission of pollutants using energy and matter per GDP is a challenge. However, this picture is showing implicitly, secondly, that also during this form of activities, we are modifying fundamental ecological cycle. Energy flow, nutrient circulation, but most important, water circulation. And in my lecture, I will try to show how and to what extent understanding how water in process of evolution and ecological succession was shaping the biota, and how to, using this understanding, we can reverse degradation of planet and get to the dynamic equilibrium between resources and society, global society needs. So one of the results of degradation, this biogeochemical cycle, is degradation of soils. And we know that society can accept that we'll not get a new type of computer, but will not accept if they do not get food, for example. And progressive degradation of soil in such scale can affect this great extent. How we can reverse the process? I think the interplay between biota, understanding biota dynamic, organic matter, dynamic or organic matter decomposition, all these three elements are somehow related, and I will show further how we can eventually try to do it. In reality, I use the case of Ethiopia, where recently on request of Ministry of Water we're developing the program. Effects of degradation of soil and water resources is, first of all, on left side we have an example. On left side is a road, a landscape which is not supplied with water. On the right side we have a landscape which is just supplied with small amount of water. The same road, just left and right. And we can see also that in the right side there's plenty of white points in the green space. There are birds. So it's showing that despite human settlements, despite intensive agricultural use, if water is in the landscape, the biodiversity also somehow can be incorporated and can maintain in the landscape. However, the intensive degradation of zone and also development of different type of, let's say, use of resources, like for example pastoral, intensification pastoral land use, is changing the nutrient pathways because big density of, let's say, grazers collecting the biomass in the catchment and becoming traditional way, twice a day drinking, is providing, let's say, roughly 70, 80, 90% of collected nutrients to the rivers, to the lakes, to the reservoirs. And obviously consequences are that there's no recirculation of phosphorus, nitrogen landscape, but permanent transfer to the aquatic system and accumulation in the reservoirs, lakes and coastal zones. So, overgrazing also generates accelerated erosion. Erosion is increased sedimentation of reservoirs, it's reducing the water reserve this way, and in consequence further eutrophication and elimination of tourism potential. This is Lake Tana in Ethiopia, which as you see has a nice potential condition, but because water quality is not used intensively. So now I think is question how to reverse all cascade of these processes which are interconnected, which I show on these pictures. And generally we can say that all things which have done in 20th century humanity is making the landscape dry, because in agricultural landscape and in the city we developed technology to send water so fast as possible to the sea. And this is an example of deforestation in the lake catchment Gumera River. And you see on the 70s when they start deforestation due to the demographic explosion, the daily evaporation was 4.8 millimeters, and 30 years later almost twice higher. So it means that fraction of precipitation which we are losing to the atmosphere was doubled, because we are just shifting from biological buffering of processes, geophysical process, toward the physical process, pure physical, which immediately make all parameters more stochastic. It means oscillating in bigger range. What is even more impressive, in some hydrological handbooks you can find only this relation. It means that deforestation is good recipe to increase water yield in the river. Yes, because if you deforest the catchment, in this moment you accelerate the flow and the amount of water is increasing. However, if we keep in mind that we double evaporation, we accelerate transfer to the river, in this moment catchment which should produce the food and provide ecosystem services, biodiversity is getting very dry in this moment. There's no enough energy to transfer this water which is increasing in the river back to the field to irrigate. Whenever budget will be closed, and this is not way to do it. Additionally, accelerated flow is increasing erosion. So all this process put together has to be somehow now controlled in reverse. So at that point, it's worth to think what is evolution relation between man and environment. I think at the beginning, in the geographic era of our geographic discoveries, we were thinking that nature has unlimited potential. And so we generally, the conquest of the nature was kind of general idea. However, industrial era even increased the exploitation of the nature. We just erase of the forest in some big area of continents. However, at that time, the increasing interest in biology, like Lynn knows, demonstrate that we are dealing with very interesting diversified component, or biotic component. And this consciousness of biodiversity started to be raised as a consequence, protection of nature, this maybe not work to preserve this, was raised. Further understanding of ecological succession process means the ecosystem is dynamic, is changing and getting more mature, and also is somehow changing the patterns of fundamental processes. It was connected with increasing evidences decline of cultural and aesthetic values, and as a fact, we created fundamentals for restoration ecology. Restoration, which obviously is important in some area, but for example, we cannot restore 70% European landscape, which is agricultural land. So this is obviously it must be agricultural land. So that's why, in a certain moment, when we start to increase our consciousness, the decline of ecosystem services, it means services which determine ability to persist on the earth, it's come to regulate processes. Regulate processes toward the goal. It means using, and there's profound understanding between biota and abiotic factors, mostly hydrology, and to achieve the enhanced carrying capacity of system. Why enhanced? Because we are approaching the carrying capacity of global environment. So it's not enough only maintain given state or even declining potential, like in case of soil degradation. So an ecohydrology is system approach based on transdisciplinary science, putting together not only two disciplines along one concept, regulation concept, but also explaining how to use ecosystem processes like management tool, complementary to technologies. And obviously, the goal is enhancement ecosystem carrying capacity, water, biodiversity, resilience, ecosystem services for society, and key element is dual regulation. Dual regulation, which means that in situation like on left side on the landscape, when we modify circulation of water by deforestation, we make a, let's say, additional supply of nutrients to the landscape, and we are only half of the nutrients taking with the crop, and half of the nutrients we are still in the soil or transferred to aquatic system. We have to rather think how to put a mosaic landscape, which will be more resistant, and also we have a more closed nutrient cycle, and also important elements of the mosaic will help to recirculate the water and increase, changing the heat budget, increase the water resources retentiveness. So this is true or not. An example from Diana spine is showing what happens as effect of overexploitation resources in upper part of catchment, and when this overexploitation of water was stopped, in 3 years ecosystem come back to this stage. This is showing the resilience of the system. So, and other word showing how water is important driving force just to regulate the biotic dynamics and biodiversity and services. How to regulate system? This question already